Good evening, students. Welcome to our class today. So for today, we are going to discuss about a new lesson. We're going to have the equations transformable to quadratic equations, including rational algebraic equations. Let's start with an activity, think, pair, share. In this activity, you will be given a set of quadratic equations that you need to get the roots. So find the solutions of the following quadratic equation. This is to prepare you for our next discussion. We have x squared minus 4x plus 4 equals 0, x squared minus 3x minus 10 equals 0, and 2x squared plus 2x minus 12 equals 0. So I'm going to give you time to get the roots of the following equations. You can use any techniques. You can use factoring, completing the square, or using quadratic formula. Okay, time's up. So let's have the solutions. So the roots of the quadratic equation for our number 1, x squared minus 4x plus 4 equals 0, is 2. So how did we get that? We can use factoring. So if we are going to factor this one, we're going to have x minus 2 squared equals 0. So that means you're just going to have x minus 2 equals 0. So we can have the root x equals 2. How about the second one? We have here x squared minus 3x minus 10 equals 0. So what are the roots of x squared minus 3x minus 10 equals 0? We have x negative 2 and positive 5. So by factoring, you can factor this one as x minus 5 times x plus 2. And if we're going to get roots, so by zero product property, x minus 5 equals 0. And x plus 2 equals 0. So x equals positive 5 and x equals negative 2. We proceed to the third example. We have 2x squared plus 2x minus 2 minus 12 equals 0. So the roots are negative 3 and positive 2. So how did we get negative 3 and positive 2? So if we're going to factor this one, we're going to have 2x plus 6 times your x minus 2. So by zero product, we're going to have 2x plus 6 equals 0 and x minus 2 equals 0. So we're going to have 2x plus 6, 2x equals negative 6. Dividing both sides by 2. So the value of x is negative 3 and positive 2. So we need to get the roots for the next slides also. So there are equations that are transformable to quadratic equations. These equations may be given in different forms. Hence, the procedure in transforming these equations to quadratic equations may also be different. So take note of the given different forms. So when you say different forms, so we can see here some equations in the rational equations. You can have some equation in the fourth or in the second degree. So let's have on the examples on how we're going to transform them. Once the equations are transformed to quadratic equation, so then they can be solved using the techniques learned in the previous lessons, like factoring, completing the square, extracting the roots, or using the quadratic formula. So in solving your quadratic equations that are not written in standard form, let's have the first example. We have x times the quantity x minus 5 equals 36. So this example is not yet in standard form or in written in quadratic equation form. So we need first to multiply your x to your x minus 5 by distributive property. So x times x and then x times 5. So we're going to have x squared minus 5x equals 36. And then we're simply going to transpose this 36 inside, which will make it negative. And that is equal to x squared minus 5x minus 36 equals 0. So since our given is already written in standard form and it is already a quadratic equation, we can already get its roots. So given is x squared minus 5x minus 36 equals 0. So we may factor this one. The factors are x minus 9 and x plus 4. Then by zero product, this one is a factor. Then by zero product, we have x minus 9 equals 0 and x plus 4 equals 0. Then we can get the roots, which is 9 and negative 4. So that is a simple distributive property and transposition. So the roots are 9 and negative 4. Next, we have here the square binomial of x plus 5 and x minus 2 equals to 37. First, we have to simplify the square binomials. So if we're going to simplify the square binomial, so square first your first term, x times x. That is equivalent to your x squared. Square of your second term, 5 times 5, that is 25. Plus, multiply this 2, so x times 5, then times 2. So x times 5 is 5x times 2, that is 10x. Same thing with this second binomial. So x times x, that is x squared. 2 times 2, that is positive 4. X times 2, that is negative 2x, times 2, that is negative 4x. So we're going to have the following. So x squared plus 10x plus 25 plus x squared minus 4x plus 4. Then after that, we're simply going to combine the like terms. So you have x squared plus x squared, 10x minus 4x. We have 25 plus 4. So x squared plus x squared is 2x squared. 10x minus 4x is 6x. 25 plus 4 is 29. Then, how did we get this negative 8? We are going to transpose this 37 inside. So we're going to have 29 minus 37 equals 0. And 29 minus 37 is negative 8. It's already written in a quadratic equation in standard form. So we're simply going to factor. So 2x squared minus 6x minus 8 equals 0. We have 2x minus 2 times x plus 4 equals 0. 2x minus 2 equals 0, and then x plus 4 equals 0. The value of x is 1 and negative 4. How did we get 1? So 2x equals 2 then divide both sides by 2. Again, we have 2x equals 2. Divide both sides by 2. So we're going to have x equals 1. Then this one, we're just going to transpose. That's why it's negative 1. So there's an easier way so that you are not going to have 2x squared. Since 2, 6, and 8 are both divisible by 2, you can all divide this by 2. We're going to have x squared plus 3x minus 4 equals 0. So that factoring will be manageable. So you're going to have x plus 4 times x minus 1 equals 0, which will lead you both to 1 and negative 4 as well. So that means the roots for your quadratic equation is 1 and negative 4. Next, we have here a rational algebraic equation 6 over x plus x minus 3 over 4 equals 2. So how are we going to solve that? First, we have to get the LCM, the least common multiple for this one. So the least common multiple is 4x. Since we have here your 4, your x, multiply lang po natin yan. Then we multiply the whole equation by its LCM, which is 4x. Okay, then we proceed to its whole process. Now we're going to solve. Again, the LCM here is 4x. Multiply that by 4x. Then we're going to multiply. So 4x divided by x. Simply cancel the x here and the x here. Then 6 times 4 is 24. Then 4x divided by 4, cancel the 4. Then x times x. Kung cancel natin yung 4, magiging x times x minus 3. So x times x, that is x squared. X times 3, that is 3x, equals 2 times 4x, that is 8x. Yeah. Then we're just going to transpose your 8x. And let's repeat this part so that it will be clear with you. How did we get 24 plus x squared minus 3x then equals 8x. So again, the LCM is 4x. Then we simply multiply both sides by 4x. So tabi-tabi natin para mas kita nyo. 4x times 6 over x plus 4x times your x minus 3 over 4. Ayun na kasi yung 2 times 4x. So 4x times 6 over x, simply cancel your x. Then 4 times 6 is 24. In this part, we canceled naman yung 4. Then x times x is x squared. And x times 3 is negative 3x. So that's why we arrive at 24. And x squared minus 3x. And then 2 times 4x is 8x. Okay. I hope everything is clear with that part of the example. And after that, we're just going to simply transpose and combine the like terms for this example. So we proceed. So we have here your x squared. Now 24 plus x squared minus 3x equals 8x. And we have x squared minus 11x plus 24. Wow, how did we get that, ma'am? So we're just going to simply combine the like terms. I'm going to write first here x squared then minus 3x. Then I'm going to transpose this 8x. Since it's positive, we're going to make it negative 8x. Then write our plus 24. Then just combine 3x and 8x. Both negatives are going to add so that it becomes negative 11x. Then we're just going to simply factor that one. And we're going to have factors x minus 3 and x minus 8, which will lead us to the roots positive 3 and positive 8. So the roots of our rational algebraic equation 6 over x plus x minus 3 over 4 plus 2 is 3 and 8. How about this one? So the same thing we have to get its least common multiple. So the least common multiple for this one is x minus 2. We're just going to multiply all by x minus 2. By multiplying, we're going to have the following solutions. How? So in this part, so first we have x minus 2. Going to solve this little by little times x plus x minus 2 times your 8 over x minus 2. How? I just simply distributed this x minus 2 to x and your 8 over x minus 2 so that we can see the solution. So first, multiply this by distributive property. X times x squared. X times 2 is negative 2x. While on this part, we simply cancel your x minus 2 and plus 8. So we have x squared minus 2x plus 8. So in this part, we're going to do the same. So 1 times your x minus 2 plus your 4x over x minus 2 times your x minus 2. And this is much easier. So 1 times x minus 2 is simply x minus 2. Then cancel our x minus 2. So we're going to have plus 4x. So that's why we have x minus 2 plus 4x. Then we're just simply going to combine the like terms. So we write first all on the left side. So we're going to write it here on top, x squared minus 2x. I'm going to get this x minus x and also this 4x. So minus 4x. Then I'm going to write the constant plus 8 and then plus 2. Why plus 2? It's transposed to the left side equals 0. Then combine negative 2 minus 1 is negative 3. Then after that, negative 3 minus 4 is negative 7. So we're going to have x squared minus 7x. Then 8 plus 2 is plus 10. So we're going to have the solution x squared minus 2x plus 5x minus 2. We're going to have x squared minus 7x plus 10 equals 0. Then by factoring, we're going to have x minus 5 times x minus 2. And the roots are 5 and 2. So the roots of our rational algebraic equation is 5 and 2. So let's have a problem solving here. Read the problem and try to solve using the lesson that you learned. So Jesse and Mark are planning to paint the house together. So Jesse thinks that if he works alone, it would take him 5 hours more than the time Mark takes to paint the entire house. So working together, they can complete the job in 6 hours. If they work together, the equation formed is a rational algebraic equation 1 over m plus 1 over m plus 5 equals 1 over 6. So we have, so let's solve this one. So we're given with 1 over m plus 1 over m plus 5 equals 1 over 6. First, we need the LCM. So the LCM for this part is m times your m plus 5 times 6. So we're going to multiply the whole equation by 6m times m plus 5. 6m times m plus 5. We're going to do this step by step. Let's start with 1 over m. We're going to multiply 1 over m. So we're going to cancel m. So 6 times m plus 5. We're going to result with 6 times m plus 5 times 1. We're just going to multiply it later. Then, we are going to have multiply it with m plus 5. 1 over m plus 5. We're going to cancel the m plus 5. And what's retained is 6m times 1. So that is simply 6m. How about if we're going to multiply it by 1 over 6? So what's cancelled is 6. Then we have 1 times m times 5. 1 times m plus 5. Now we still have the m times m. So we simply multiply 6 times m, 6m, 6 times 5, that is 30, times 1, it's just the same value, plus 6m, equals m squared, that is m times m, then m times 5 is plus 5m. So since the positive squared value is on the right side, this is what I'm going to transpose to the left side, right side. So we're going to have m squared plus 5m minus 6m minus 6m, then minus 30 equals 0. Just going to combine the like terms here. So m squared, 5 minus 6 is negative 1. Negative 1 minus 6 is negative 7. M squared minus 7m minus 30 equals 0. So our given is already written in standard form. What we need is to factor our m squared minus 7m minus 30 equals 0 to get the roots. So we need to get a factor. So the factor of our m squared is m. So we need to think of factors of 30. The possible factors of 30 is the factors of our given is we have m plus 10, or no, m minus 10, m minus 10 times m plus 3 equals 0. By zero product property, m minus 10 is equal to 0, and m plus 3 is equal to 0. So the roots are m equals 10, and m equals negative 3. Given rational algebraic equation there. So we have to think of a way on how we're going to solve that. So first, we have to simplify the expression by applying different mathematical techniques. Write the resulting equation in standard form and find the roots using different techniques. And for your post-evaluation, find the solution set as following.